You're in for a treat.
Tuesdays and Wednesdays and Thursdays.
2 West.
6 to 7:30 p.m. Eastern Time.
We got new hours because we're nerdish.
And we're in our 20s despite our looks, so we gotta do things in the evening time over the summer.
Correct, but not too late because, as Levi said, we're in our mid-20s.
Not our early 20s.
And not our late 20s, the mid-20s.
Yes, we're the Goldilocks of 20s.
That's right, I shouldn't have laughed. I gotta keep it cool, because this is our intro rap, where we keep things cool.
We're very cool, so cool we might want a dance break.
Hey, thanks for watching our dance break.
Now, back to the really serious stuff.
Like Brady
And Levi.
and Brady too. We're the 3 members of the Nerdish crew.
That was perfect. We didn't plan that.
Not at all. We don't plan anything. If you couldn't tell by this rap. That was the one thing we rhymed,
That was the one thing.
which makes it a rap.
Yes, all raps have one rhyme.
We'll see you on 2 West.
Yes. 2 West
6, 7:30 p.m.
Eastern Standard Time.
Keep watching, because it'll turn into us, but probably not wearing the wigs.
Yes, and we'll be much more responsive to whatever you have to say.
You could ask us questions right now. We will not answer them.
Also, we take no responsibility for anything we've done in this pre-recorded session.
Yes. Any lost items, Nerdish is not responsible.
Right, we don't have anything to do with it. We're very different people in the present than we are from when we're recording this video. You might say we are the pupae of Nerdish right now, and in the future we will be the moths.
The
Because moths are the
disgusting
most-
gray moths.
Yes, those gray moths that you hear, they're
Yeah.
like the bats of the flying community.
The wings are leathery. They're leathery wings.
Very leathery.
They're basically butterflies, but we hate them.
Yes.
They're the rodents of butterflies.
This is true.
Right?
Just like the ACT is the rodent of the SAT.
I don't agree with that. I don't agree with that at all. Hey, it's Nerdish.
And us.
You know what that means.
It's tonight.
Right now for your viewing
Benefit.
benefit and pleasure.
Benefit.
Hope you're enjoying your leisure time. Use your leisure time to enjoy our pleasure. Pleasure is a fun word.
Did you do this Matthew one?
Yeah.
Oh, yes, you did.
I did. Did
Okay.
you?
No, I didn't, because you did it.
Very good. Levi. Oh, look who's here.
Hey!
Prod Vanix. I forgot who that was.
Yes.
Trapsy.
It's not Drumsy.
Dude, Trapsy and Drumsy are both 6 letters and then with ZY. That's why I confused them.
No, Drumsy ends with SY.
Are you sure?
Yes.
Yeah, but Trapsy ends with ZY. What?
Hey, do you have any questions for us?
Yeah, do you have any questions? Or are you just stopping by to say hello?
Do you always just say hello?
Yeah, is that what you do?
You just say hello?
Is that just like a greeting in your language
When
or
people
something?
ask you to ask questions, do you just say hello?
Maybe you could make it like a question, like hello? And we'll be like, yeah, hello.
Or is it like dangerous jello?
Hello?
Yeah. It's jello you get if you're a sinner.
Jello, it's me. I'm
Sinner.
doing some practice. Right, nut. Our nut. No questions yet.
What does that mean?
It's supposed to be just RN right now. Or just R now, but he said R nut.
I think we have to read it backwards.
Oh, I can do that.
No, you can't.
Yes, I can.
No, you can't.
Jag ser
Oh,
på Anita
gosh.
och ett litet prank.
You're the worst.
I almost
Did
finished
that
it.
one.
En måste gå in dit.
There we go. Let's do a fun one.
I think this is the only one left.
Let's do that one then.
If you insist.
I do insist. Hey, we got 4 viewers. Hey, Not Koozie is in the house tonight. Or this afternoon. And you're still not Koozie. How's it going? Not Koozie. Not. Whose question is this?
This is robots question. I think it's the last robot question.
Last.
The last of the robot questions.
Kind of reminds me of that movie, The Last Mimsy. You remember that?
The last two?
The Last Mimsy. You know what?
No.
I don't know why I asked you about a very obscure movie that I don't even remember that well, but I did watch The Last Mimsy, I think on an airplane. There's certain movies that are like meant for watching on airplanes, you know?
Yes.
Yeah.
Like Airplane. Or any movie with an airplane crash.
Oh God. Levi, that's the opposite of what people
Oh,
think.
okay.
On
mobile devices, global voice traffic has been growing by approximately
2 petabytes per month.
while global data traffic has been growing by approximately
7% per month.
at the end of 1 month in
2007.
each of the two traffic volumes equaled
110 petabytes per month.
what was the total expected traffic, data and voice combined,
4
months later? Round to the nearest.
petabyte.
Again,
Yeah.
I have no
I know.
idea.
Why
what
did we
happened.
thought we'd be able to do it? Because I only said
I have
certain
no
things.
idea what this question
All
is
right,
about.
global voice, 2 petabytes per
Yes.
month. Global data traffic, a separate thing, 7% per month. 1 month, each of the two traffics equals 110. 4 months later.
Okay, so
very
let's
good.
just do
okay,
voice.
this is
we
so
have-
easy.
Oh, it's so easy.
Oh my gosh.
For everybody.
Okay.
So voice is 2, I'm going to do lowercase pb a month.
Per month.
It's growing by, so plus 2 pb per month.
Data
And then data
plus 7%.
plus 7%.
Now, Levi, would you say that one of these is growing linearly and one of these is growing exponentially?
Yes.
Yeah, but I don't understand which one that is.
So a linear growth means you have a constant slope. In this case, with voice, you have a constant slope. Every month, you go over 1 month, and you go up 2 petabytes.
Fraud Vanity. If I don't get 1500 plus on August SAT, I'm going to drop out and sell eggs.
Yes, first you need to get the eggs.
Yeah, it's going to be a whole business. You can't just sell them if you don't have them already.
Yep. Unless you have nerdish
Money.
money.
You can buy nerdish eggs.
Yeah.
Levi and I lay
We
eggs
lay eggs.
every now and then. We sell them on our nerdish market for nerdish money. Yeah. Oh, by the way, you got to have multiple baskets because if you're going to try to sell eggs, do not put all your eggs in one basket. I think Brady should be fired if he doesn't know about linear functions. Fired would imply that I have a job at Nerdish.
And a job would imply income.
Yes. Both of which are false and non-existent.
Yes. Like linear functions, which don't actually exist.
What
Right?
does that mean?
It means invalid truth.
They function.
Okay. Okay, so these are the two growth patterns. Wait, you don't get paid for tutoring? We don't get paid for doing this
We
right
don't get paid
now.
for doing this.
Who's
We get-
paying us?
We get paid for tutoring. Yeah, you're not paying us.
What does that mean?
Oh. Oh slash. I think it's like, oh slash.
I think so too. That's my first guess as well.
I have valid reasons for believing
No, you
that that's
don't.
what
No,
it is.
you don't.
All right, can we start?
Yes, at the end of 1 month in 2007, each of the two traffic volumes equaled 110 petabytes per month. Sure.
All right, so we have.
What was the total expected traffic 4 months later? Oh, okay.
It's not too
Cool.
bad. Okay.
It's a person waving.
So I'm gonna get my prime. Wait,
Oh,
let's see
that's
what it
cool.
Oh, and it was a little person waving, like, hey. Oh, you can't really see my hand.
How many fingers am I holding up?
That's another couple of.
Thank you, Alan.
Thanks, Alan.
You
You're
don't
gonna-
have to. I know that we're making you, but keep in mind you don't have to.
Oh, we
Yes,
do want the questions.
We want the questions, and we want you to spread us like the plague. Go back to, where is that plague from? I think it's from Bubon, right?
No,
It's not?
no. I think bubis was like the Latin term for like the.
No, that was the pus that came
right,
out.
right. That's why they called it that. It was
Yeah.
originally from Asia.
Yes,
Yes,
right.
because it.
Where all pus is from.
Spices, gold, and pus.
Uh,
Anyway, okay,
hey,
so.
Bert, what do you think BRB means? Do you think it also means O slash?
Oh, slash. All right. So the voice is going to be 110 plus 2 per month. That is a 2, not a Z. And then this is going to be D is going to be equal 110 times We're increasing by 7%, so our multiplier is 1.07 to the power of the month. The power of the month.
Robots in disguise.
Yeah, something like that.
I think that's how it goes.
So, it's been 4 months in this question. So V is going to be equal to, I should just put it over, I don't know, what? I didn't organize this at all. Okay.
No, you
V
didn't.
is going to be 110 plus 2 times 4 months. D is going to be 110 times 1.07 to the 4th. And the question is, what is the total expected traffic combined? Bread reduces bubonic plague rates. Oh, that's what BRB stands for. Slayer Darth. Ooh, excuse me, that was pretty good. I'm gonna get my the calculator.
I don't believe you.
You don't know. You don't know what I do with my calculator.
Yes, I do.
All right, fine. This is clearly 118. It goes up by 8 petabytes over the course of those 4 months. 118. This one, I would not be able to tell you off the top of my head. 1.07 to the 4th. Is that times 110 equals this. That is some exponential growth right there. 144.19. So you add it all up. This is the combined. That's going to be 262.19. They say round to the nearest PB. So I will say 262 jars of peanut butter. Wait, Levi.
Yes.
I think I understand that this is linear and this is exponential.
Yeah.
But where does that graph come from?
I don't quite mean... What? It's just a picture. I just drew it. It's unrelated to
Oh,
the
it's
problem.
from... Oh, I see.
Yeah.
Even though it's got the same words as what's in the problem?
Yes.
Okay.
So
yeah.
data always follows an exponential curve.
Oh, that's good to know.
Yeah, all data is exponential.
Okay, I should just remember that.
Yes,
I
and
should
all
tuck that
voices are
away.
linear.
I got a pretty linear voice.
Yeah, you do.
Yeah. That's linear, but then exponential.
Beep, 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 beep. Stop. Why did you do that?
Well, I don't know. You did what would happen if I tickled you, so I decided to tickle you.
Oh, that works for me, I guess.
Dude, I'm sorry that I'm in a good mood.
Why are you in a good mood?
I don't know.
What
dude.
are all these questions? Alan. Oh my gosh.
Alan, you dirty dog, you slimy slug, you slippery, slippery sloth. You.
Hold up. Links might be spoopy. Alright, we'll leave it here. That's actually what it says.
Like from Zelda? Like multiple links?
No, I think like sausage.
Broken violence.
Do you always get anti-violent when you think something's funny? Every time.
Well, I never condone. Get rid of the answers.
Oh. Why?
We don't like those. Just because I want to make this bigger. No, keep the question.
There's the question.
Good.
Alan.
Make it bigger. Yeah.
Stop it.
Wait, let me go ahead and just pull it.
Oh,
Yeah, thank
you're very
you.
bad
Okay,
at that.
yeah. Thanks.
All right, Bird.
All right.
Maybe I'll just draw this one.
Maybe.
That seems best.
In triangle ACE above, BD is parallel to AE. If BD is equal to 19, this is kind of tough. Leave.
No, it's not.
If BD is equal to 19 and AE is equal to 13, what is the value of CD over DE? Oh, this is fantastic. Well, so those two horizontal lines are parallel. And that's great to know, because what that tells me is that we have two similar triangles. Think about it. Both these triangles share the top angle, C. If we can prove that they share all the same angles, or really just two, because then the third one's implied because all the angles have to add up to 180, you've proved similar triangles. Similar triangles are angles that have the same, or triangles that have the same angles, but are just scaled up and down versions of each other. So if one of the sides is now twice as big, the other sides all have to be twice as big as well. So the fact that we have these two parallel lines, and Levi is about to, so BD is 19. You already put that. Okay, A is 31.
We want CD
over DE. Very good.
You know what I learned from that podcast today?
What?
That decimate comes from
10th?
Yeah,
I never-
killing
right?
1/10 of them.
Or no, leaving 1/10.
No. It's killing 1 out of 10 men.
Oh.
They wouldn't kill 9 of their
9/10.
10. That would be decimating their ranks.
That'd
Okay.
be reverse decimation.
Yeah.
All right, the fact that these are parallel tells me something very important. These angles here will be the same.
Because they're corresponding angles.
Yes, they are. And these two angles will be the same.
What about those two angles?
Absolutely not.
Okay.
Well, yeah, these two, it's just one angle that both triangles share, okay? If you're
Angle.
wondering,
Yeah.
if you're wondering why that's the case, if you have two parallel lines and you have a transversal, which is a line that's not parallel going through them, then the angles that are in the same position have to be the same. And that's what we have here. Although these two lines do not continue, they're parallel lines. This is a transversal. This situation is exactly what we have here. Anyway, so now we prove that these triangles are similar. So there's a sequence of steps that you should always recognize. Number 1, prove that they're similar triangles. Number 2, if they are, use proportions to find missing side lengths. In this case, they're asking for the ratio of CD to DE. Now, DE is kind of a tough quantity because it's not an entire side length. It's just the portion of CE that's not CD. All right? So this is going to be kind of tricky, but I think we can do it. Here's an important thing, the scale factor between them. The scale factor from the small triangle to the big triangle, we only have one pair of sides, but they're matching, which is great, because that'll tell us exactly what the scale factor is. So, scale of the small triangle to the big triangle, so from CBD to CAE is 19 to 31. What a great ratio. You can't simplify it at all, because they're both prime. So, let's start labeling some things. I'm going to call this X. I'm going to call this right here Y. And I'm going to call, well, the entire side length in that case would be X plus Y. So I have this ratio of small triangle to big triangle. I'm going to make the same ratio into a proportion. So 19 over 31 is going to be equal to, now I'm going to look at these sides. So we did the bottom sides, that gives us our ratio, which is great. I'm going to set those proportional to these sides. The small right side is X. That's what we called X. And then the big right side is this entirety of X plus Y. What they're asking for is the ratio of CD to DE. So we already called CDX. What we don't really know here is how do we calculate Y? If we can move things around a little bit and somehow get, basically the ratio we want is X to Y. CD to DE, we want to try to eventually get this. Remember, fractions and ratios are pretty much the same thing, just written in a slightly different form. So if we can somehow get X over Y, that will give us our ratio. So the way to get yourself out of this, cross multiply. Fractions that equal to a fraction, cross multiply your way out of there. Is equal to 31x. We have 19x plus 19y is equal to 31x. My goal is to simplify this and not solve for x, not solve for y, but solve for x over y. The way to do that is first, let's just get x by itself. Let's just isolate x. So if I want to do that, I'm going to have to move this over here. So I'm going to subtract 19x from both sides. 31 minus 19, I believe that's 12. Yes. So this is going to give us 19y is equal to 12x. Okay. And then to solve for x, I divide by 12. So taking this, I'm just going to put it over here for a sec. This gives us x equals 19 over 12 times y. We're very close. If we want to get x to y, or x divided by y, we need to change this side from x, which it currently is, to x over y. The way to turn x into x over y is to just divide it by y. That is what will make it look just like that. And if we do that to the other side as well, that's going to cancel this y out over here, leaving us with x to y is 19 to 12. let's just do a sanity check. X looks bigger than Y. So 19 to 12, that 19 is bigger than 12. I would feel pretty good about that. Let's take a look at our answers. Yeah, one of our answers is 19 to 12. So we did it. Yay. Let me know if there's any confusion on that. I will pull up the next question.
Oh wait, let me do something real quick.
Oh, absolutely. I'm glad you brought it up.
I think you can also say that because the scale factor is going to be the same, so this is your ratio. So you could set x equal to 19, and then you could set 31 equal to x plus y.
Oh, absolutely.
And then you get y equals 12, and then you have 19 over 12.
Yeah, that's very true. Yeah.
Yes.
So what Levi did here is a fast shortcut. It is based on the assumption that your x could actually be 19 itself, and your y could be just whatever adds with 19 to make 31, which we wouldn't know positively. However, because we end up just calculating a ratio, it doesn't matter. It might be that x ends up being twice as big as 19 and x plus y is twice as big as 31. Either way, the ratio will still hold. So you can absolutely do what Levi did. It's actually a lot faster than what I did. Levi just broke the system. Dude, they're loving you right now.
Dude, the system is so broken. Oh, okay.
Go. Double drinks for Levi. Wait, you got a follower.
It's C. Thruck.
C. Thruck. And it's
Hi,
Ring Matthews. You know, I've often noticed there's a connection between C. Thruck following us and Ring Matthews. Just saying hi.
I've often noticed that too.
I guess you could say that we've often noticed that.
We're going to do the next question.
By we, you mean you.
And I mean me.
Yeah.
Oh, boy. This looks...
Is this was question?
Oh, wait. Actually, let's do was question, because that was 2 Alan questions.
You're absolutely right.
And then let's do a what question. We'll go back to... Wow, there's a lot of things going on here.
People are reacting.
Okay. Sucky Charms is here. Hey, what's up?
Oh, fantastic.
All right. What do we got here? All right. Bird's going to erase that. We're going to see how we do on this. We might not be able to do it.
Oh, we're going to do it.
Oh, we are?
Yeah.
Have you seen this?
No.
Have you not?
I have confidence in our abilities.
I have confidence.
Just general confidence?
I have confidence, but... You know?
Yeah. No, I mean, that makes sense. If you put it that way. But if you don't put it that way, then it definitely doesn't make sense.
A gem cutter. Ooh, that's exciting.
Wasn't one of your great uncles a gem cutter?
Yes.
Didn't he live in like a cave with a bunch of dwarves?
Yes.
Wasn't he a dwarf?
Yes.
All right.
Okay. A gem cutter wants to trim a gemstone that is approximately, I'm going to read it here, approximately a regular octahedron. Okay, so it's
an eight-sided shape.
Why not just say it is? Whatever. With edges measured in millimeters. She will remove imperfections by reducing the length of each edge. Oh, I get it now. By X millimeters. Oh, that's very interesting. The approximate new surface area is given in the function. What is the current length of each edge?
Oh, this is fantastic.
Oh boy. Okay.
This is absolutely fantastic.
I have a question. For those who submit questions from an online medium, which sites do they tend to originate from?
What's that one that people use a lot?
So Khan Academy is super common. I think, is this Khan Academy? This looks like Khan Academy.
It does.
And then there's also UWorld.
UWorld, that's what it is.
Yeah.
Yeah. This is from Economy. Deep Blue, any SAT motivation tips? Watch Nerdish. You'll get motivated.
Yep.
I watch Nerdish all the time.
Yep. It's flipped for us, though.
Yeah, but we're watching it from the other side. But we're still watching it just like you guys. We also type it with questions sometimes. Oh, man, this is awesome. Okay.
56.25.
Okay. Okay. Was given in millimeter squared by this function. What is the current length? All right, so she reduces the length of each edge by x, and that is the input of the function. So whatever she reduces it by, we take that, plug it into the function, and we get the new surface area. So what is the current length of each edge? Oh, this is very interesting. Okay.
The surface. Wait. So it's a regular octahedron.
Yeah.
Well, how do we find the surface area of an octahedron? Octahedron has 8 faces. Is that the situation?
They're all triangles. Yes.
They're all triangles. So
Yep.
we have, and it's from each edge. So let's draw one of the triangles.
It's basically a square pyramid placed on top of a square pyramid that's going downwards instead.
Got it.
Yeah.
Yeah, I just want one face though.
Okay. I
So
will draw this over here.
If this is the face, then we have the original. What is the current length of each edge? Ooh, this is going to be fun.
Okay, and then we also have this right here, and then we have it going downward.
Isn't the bottom always pink, or no?
You're right, it's always pink. I forgot.
Don't do that, don't do that, don't do that.
You just said that.
I was lying.
You were you
And
told
now
me
we're stalling.
you would never lie to me.
Okay, so one of these faces, we're pulling off an X from here.
I don't like the way that looks.
That's an X that we're pulling off, but we're also pulling off an X from here. We're also pulling off an X from here, yes?
Okay, well, okay, so this also goes there. This also goes there.
Yeah.
Okay, that's not my favorite drawing I've ever
No,
made.
it's not your best regular octahedron.
Yeah, okay, whatever.
All right, so we're pulling off X from each of these, right, Brady? And the area of this triangle is going to be, let's say S is the original side length. So what is...
Don't use S because they're using big S for surface area.
Fine. So
Use L.
L for the
Yeah.
original... I don't like L. L is
Original
weird.
length.
Let's use Y for the original side length.
Okay,
No.
sounds good. That's fine.
Okay, so the original side length is Y. So the area of one of these triangles is going to be Y times... What is the quick thing? It's
Root
rad
3
over-
H
Yeah.
over 2.
Root 3, so it's root 3 Y. So Y root 3 over 2? Is that what it is?
Yes, I believe so.
Just double check. That's 36. So this is Y over 2. And then, therefore, that would be rad 3Y over 2.
Over 4,
times
over
Y.
4.
Yeah, over 4.
Wait, but then
No,
times,
it's Y
times
squared.
1/2.
Y squared.
Because then this becomes...
Isn't it Y squared?
It's X squared root 3 over 4. So Y squared root 3 over 4.
Yeah,
Yep.
yeah, okay.
Yeah, Y squared.
Yes, yes, yes. Very good. Look at us. I haven't tackled geometry in so long. Yeah, tackle it, dude.
Yeah.
Get low.
Yo, brush
Yeah.
up, brush down, brush left, brush right.
Yep.
Y squared root 3 over 4. That's the area of one of the triangles, and
Yes.
there are
8 of them.
8
so
of them.
that gives us the area of... So the overall area of the octahedron
before she starts cutting.
is 4, right? Because it... Sorry,
Yeah,
2.
yeah, yeah.
2,
Well,
2, 2.
keep it in terms of the same thing, and then just show it's times 8 equals.
Shoot. Okay.
Absolutely not. No, Kuzi, you do not need to. This is a very difficult Khan Academy question.
So,
That would
it is
never show up on the test.
Y squared root 3, but this is fine. Over 2. So now the area...
Over 4.
Over 4.
Well,
and now the
make it
area...
look normal.
You look and make it normal.
What?
Yep. So that's an octahedron here, notice. And this is going to be 2y squared root 3.
He multiplied this by 8 because there are
Right,
8 sides.
there are 8 faces.
Okay.
Now, we're going to be taking off x from all of these sides, which means that we're going to get a triangle in here whose side lengths are s minus x, right?
Okay, now that's the hard part. Each side length is now s minus x. Do we find that to be true? She cuts...
It's true. Oh,
yeah.
no, is it,
Yeah. Every edge is now x less. Yeah. You're right. So it's all s minus x now.
Is it?
Yeah. Yes. It is.
Okay.
Yeah. We're thinking
So
too hard
now
about
we have
this.
s minus x for an edge length, and therefore we have the area cut
Sure.
as y.
2.
Wait, not s, y. Right in this y.
We called the side length y. You're right. We
So it
took
should be
off
y
x.
minus
Y
x.
minus x.
What's s? It's nothing.
It's nothing.
Yeah.
Y was the original...
It's nothing. Why did you
length.
say that? What's that question?
Y was the original length of these triangles.
Yeah. So now we have y minus x. But what are we going to do with this other variable?
Squared. Root 3. over 4. That's of one triangle, and yeah.
And then the area of this octahedron is...
I see where this is going.
2 times y minus x squared rad 3.
Yes.
Yeah.
If this is our new surface area, we should be able to set this equivalent to the function for the surface area that they got, which is 3.4 times 56.25 minus 15x plus x squared. Okay?
Where x is a variable.
X is how much you reduced each edge by.
Y
is the original side length.
Yeah, and what is the current length of each edge?
We're trying to
How
solve
are
for
we going
y.
to solve for that with only one equation? Unless...
Let's solve this thing for y. It might be that it's the vertex of a parabola, in which case there's only one solution.
Okay.
It might be that. It might be that. Can you expand this?
No, we're still going to get a y squared, though.
So you want to take the square root of everything, don't you?
I don't, really. I think there's probably a better way. Yeah, it hurts our collective
This
brain
is not
too.
going to be on the SAT, don't worry. Okay.
I think there's some... I don't want the y in there.
Isn't y we're solving for?
That's true. I don't want the x in there. Or we need another equation.
We need another equation. It might be that we could... Let's expand everything. Let's see where that gets us.
Sure.
Okay. You work on the left, I'll work on the
Yes,
right. I'm going to need my phone for this.
Ooh, boy. So we have 2 rad 3 times... Oh, okay. Can you move over a little bit?
Yeah.
Hold off a sec. But then, sure.
Yeah, don't do it yet.
We don't want you to do it yet.
We don't want you to do it yet.
We're only going to do this for another 5 minutes tops because then we should do other stuff.
That's real.
Yes.
Yeah.
But we do want all 10 of the people watching right now to watch us fail.
Big time.
Yeah.
Big time.
Okay, if we can make this like a mirroring problem, but then because then it has to be true for all values of x.
It has to
right?
be.
Whereas y is a constant.
Yes.
So this is a mirroring
This is
problem
a
where we're
mirroring
going to
problem.
set up the same
Hopefully.
stuff.
Hopefully.
What is 2 rad 3? Is that
the same as 3.4?
Is that 3.1 or 3.4?
3.4? That's a good question.
I feel like it would be.
I think it should. Oh, you know what? 1.7 times. It should be.
Yeah.
It should be.
There we go. So there might be an easier way to do this.
So 3 radical. Oh, this is going to be great. Times 2. It's 3.46. Yeah.
There we go.
They said
That's
the
what it is.
approximate new surface area. So this is a mirroring one. Oh, this is great.
Do you want to finish up? And then
maybe.
we'll do yellow for the
Okay.
mirrors.
So, I mean, I already finished up.
Okay. So this, and that are the same.
I'll rewrite it.
Okay, yeah, it's probably better. So this is a mirroring problem. This is an SAT setup. This is not an ACT setup. This is way harder than anything on the SAT or ACT. But this type of mirror setup is on the SAT,
Okay.
where you are given an equation and you're told it's true for all values of x.
We totally have this.
Yeah.
All right.
So this 2 rad 3 is going to be, it's approximately 3.4.
Yes. Different color now.
And
Because
then,
they're going to think, here, let me connect these.
yeah, I want to keep it yellow.
Those are approximately the same thing.
Then this, with the y included,
Is going to be negative 51.
yeah. So that's really all we need.
Yeah, and then this right here will be a 191.25. So both of these should give us approximately the same thing. Who's going to give us this? Do you want to do one and I'll do one, and we'll see if we get something that's very, very close, which we should. I'll handle the 51.
Well, I mean, it is what it is. Whatever's in the chat now is probably true.
Well, dude, we're so close.
Okay. Yeah, sure.
We're so close. Okay, you do these, and I'll do the square.
Okay.
Okay.
We could feasibly also have canceled these out. I think that's what Matthew's saying.
Oh, yeah, that's true.
Which makes life a little bit easier.
We didn't know. Who could have told us? Divided by 4 divided by 3 square root is equal to 7.36.
Wait, is 7 and 8, right? We could just factor this, no? And this would be...
Well, dude, we're so close here.
Okay.
Let's not go...
Do that. You're going to get around. I'm going to see this. Go.
All right,
That's
fine. I'll be over here.
Yeah.
Okay.
No, that doesn't work. What am I saying? Never mind.
Okay, 3 square root times 4.
Good call, Matthew.
Divided by 51. 1 divided by x. Where is it? There it is. All right. Y is equal to 7.36. This should be a y, by the way. And then if we do the other way, so we take 191.25, we divide by 2, we divide by radical 3, and then we take the square root of that thing, we should get 7.43.
Nice.
So it's roughly between those.
There we
go. There we go.
That was fun.
I knew we could do it.
Yeah.
All right.
I don't think we did it. Wait, what's the answer? Let's see.
Hey, look, they're saying good things about us.
Here, move over. We can maybe check out. Let's peep the answer, huh? 7.5.
7.5. That's it. 7.5.
Nice. All right. That was fun.
That was fun.
That was very fun.
Yeah, we can review the explanation. An octahedron is a square pyramid on top of a square pyramid. So it is an 8-sided shape that has triangles, all equilateral. That is approximately what an octahedron is. If you don't know that, this problem would be impossible. It would just be impossible. Okay, so we drew that and we focused on, this is about surface area, we focused on what one triangle would be. So Levi made a triangle, all right, and these are all equilateral triangles, by the way. So we called the side lengths of the original equilateral triangles y. And there's an equation for the area of an equilateral triangle, and it looks like this. It's whatever your side length squared times root 3 over 4. There's a derivation for that.
That's so much smarter.
What?
So they just, because x can be anything, what you do is, what they did, their explanation is they set s of x equal to 0. So that means that because if x is so big that it engulfs the entire side, you just pulled off the entire side.
The 0, 0, 0?
Yeah, so what value of x give you?
Oh my god, that's beautiful.
That's very nice.
That's so nice.
Yeah, that's much nicer than this. This is very painful. Don't do this.
Well, no. I mean,
this was so stupid.
No, it was not.
It's so stupid.
We couldn't have thought through that until now. Okay, anyway, the area of our original equilateral triangle is this. So we want to get the surface area of the entire shape. We multiplied by 8. This would represent the area of the original shape. And then because this gem cutter is cutting off a little bit x from each of these edges, our new triangle faces will be the smaller triangle with side lengths of y minus x. Every side length was y, but now we're shaving off x from each one. So we found the new area of that, which would be the same area, but instead of y, it's y minus x, because that's our new side length, okay? So the overall surface area of this new one will be 8 times this, which gives us this thing that Levi wrote right here. This right here represents the surface area. But that's one expression for the surface area, and we know that they gave us a function that explains the surface area as well in a slightly different way. So that's these two things right here. If you were to multiply them out, you should get some symmetry here, because this should be true for all values of x. The symmetry thing here, so this is not going to be on the SAT. Oh my god, no. Absolutely not.
Unless you ask nicely, and it might be.
Basically, you match the constants on both sides of this. So 2 root 3 x squared. The only other x squared term on the other side is 3.4 x squared. Turns out these are very, very close. So these two things have to match, so that makes sense. Thank God. Okay.
So their explanation is way cleaner than ours. And they're saying if you are cutting off the entire edge, so basically in our case, it would be x equals y. So you've cut off the entire edge. That means that, of course, the surface area of the resulting gemstone is 0, and you've lost an enormous amount of money. But by giving ourselves that context, we know that s of x in our equation has to be equal to 0. So if you factor it and you set it equal to 0, you're basically finding an x-intercept. But that intercept is when your x that you're cutting off from the edge length is equal to the edge length originally. That's how you end up with a 0 surface area. So then you just take that x value, and that would be that x value is how much you would start with.
According to this explanation, we wouldn't have had to do any of this geometry stuff.
Yeah.
None of it. Don't
Just
worry about what an
factor.
octahedron is. If you just know that cutting off all of the edges would make you have a surface area of 0, the amount you cut would be the entire edge length.
That is an awesome
That's so elegant.
proof. Yeah.
Levi.
Wow.
That's so elegant. Levi.
Bird,
What?
don't go outside the box.
Why?
All right, let's do this one. You want to do this one?
Sure. Fine. Gandalf, I'm glad you're back. So am I, dear boy. So am I. Ha ha ha. Name that movie. But be specific. They both give a hearty chuckle. They're old friends. They haven't seen each other in a while. And somebody's back for somebody's 117th birthday.
Before its launch, the first stage. Also, if you are tired of these questions, you should ask your own.
Yeah.
If you're not tired of these questions, you should ask your own. There is you should ask your own questions, and that is
A constant.
what is the thing when it's not affected by other stuff? Not mutually exclusive.
Independent.
Independent.
Yes.
The need for you to ask questions is independent of anything.
Yep.
Just ask us questions.
Even if there's a nuclear bomb
Yep.
destroys everything, you should still be asking questions.
Like what?
Yeah. Before its launch, the first stage of the Saturn V rocket, which I've seen before because I went to space camp. Ooh, he's so cool. He went to space camp.
Yeah, that's what they were thinking.
Yeah, right. Held about 540,000 gallons of fuel. The number of gallons of fuel, F of t, remaining t minutes after its launch can be modeled by that function where t is less than or equal to 6. Which of the, so it must have burned for 6 minutes because you don't go past that. Which of the following describes the meaning, what is the meaning, of 19 over 21 in the context described? Very good. Okay. This is an exponential function. We're multiplying by a number over and over and over again. We have that fraction, and that's taken to an exponent. So let's imagine that exponent was 2. That means we'd be multiplying by that fraction twice. We're multiplying it by that over and over and over again. And multiplying by a number, if it's greater than 1, will make something go up. Multiplying by a number, if it's slightly less than 1, a fraction will make it go down. That is the difference between exponential growth and exponential decay. This is an exponential decay because 19 over 21 is smaller than 1. And it makes sense because they're losing fuel. So we have the exponent, which is 20t. Okay, 20t. So we have f of t.
And while he's writing that, this is, what is it called? An interpreting equations question. That's what we call it. The SAT, especially the SAT, but the ACT too, loves asking equation-related questions. Either they give you context and then you have to build an equation yourself, or they give you some context, they give you an equation, and they ask for what parts of that equation mean in context. That's what's happening here. It's super common. Do not think that you can, yeah.
Very good.
Keep going.
All right. So,
Thanks.
that's great. That's great. We're taking it to the 20t, which is interesting. So let's just think about what this would mean. If t is minutes, and so this thing is burning for not a lot of time. It's 6 minutes, then it's up in space. If t was 1, that means it would have burned for 1 minute so far. So we would throw 1 in for t, and we would be taking this thing to the 20th. So we would have 540,000 times 19 over 21 to the 20th. We would have multiplied by 19 over 1 20 times by the time we get to the first minute, okay? Every time we multiply by 19 over 21, we find something that is 19/21ths of what we had before.
Hey, is the microphone working? Is it?
He says Andrew unmute. Let me go back to... yeah, it should be fine.
Okay, alright.
Yeah. 19 over 21, by the way, just to put this in context, that's about 90%. So what that means is every time we multiply that, we're going down to 90% of what we originally had. We're going down about 10%. Oh, wait, I was talking to Kuz. Oh, he's talking to Kuz. Dude.
He's not talking to not Kuz.
I talk to Kuz all the time. Kuz and I are boys. I don't care what everyone else says. We're boys. Even though we're not. But I don't even care what I say. So we're boys. We have just taken 90% 20 times by the time that we've reached the first minute. We've gone down to 90%. Brady, are you hoping on striking Vipers tonight? How much Ethereum do you have? I'll tell you guys in a little bit. So anyway, let's go through these answers. The fraction of the 540,000 gallons of fuel the rocket had at its launch. That doesn't make sense. This starting number, this number here, tells us what we have at the start. So that's the amount that we have at the start. It's not a fraction of what we have. The fraction of the 540,000 gallons of fuel the rocket had 3 seconds after its launch. That's interesting. We're going to talk about that in a sec. Let's see. The fraction of the 540,000 gallons of fuel the rocket had 20 seconds after its launch. Let's think about that for a sec. So 20 seconds after its launch is 1/3 of a minute. So if it was 1/3 of a minute, we place 1/3 in for t. So we'd be taking 19 over 21 to the 23rds, which is 6.6. 7, whatever. Basically, we're going to multiply by 19 over 21 almost 7 times by the time we get to 20 seconds. So not really. We would have already done this fraction a bunch of times. We would have been a lot lower. That's very true. So yeah, 20 seconds is too much. We would have multiplied by 19 over 19 over 21 way too many times. And lastly, the fraction of the 540,000 gallons of fuel the rocket had 1,200 seconds after its launch. If I'm not mistaken, 1,200 seconds divided by 60, 120 over 6, 6. No, 120 over 6 would be 20. Is that be 20 minutes? That wouldn't make sense at all. Let me just make sure this sanity check. 12 over 6. Yeah, 20 minutes, which this function isn't even supposed to last for after 6 minutes, so that's going to be wrong. So 3 seconds after its launch, let's think about that. 3 seconds, but t is measured in minutes. So what is 3 seconds if we put it in terms of minutes? 3 seconds divided by 60 seconds would give us 1/20th of a minute. And 1/20th of a minute is super interesting, because if you put that in for t, basically it cancels out the 20 and just gives you 1. So we would have, getting sick of writing this number, this times 19 over 21 to the 20 times 1/20th of a minute. These cancel out, leaving us with just 1, which means we have only taken 19 over 21ths of our fuel 1 time. So that is why that is correct. That is the fraction of the fuel that the rocket would have after 3 seconds. Okay. Just a reminder, exponential growth or exponential decay. You've got a times b to the x. A is your starting amount. B is what's called your multiplier. X is whatever your input is. So usually exponential growth and decay happen over time. So the fraction at the launch would be that to the 20th. No, the launch means no time has passed yet. So our t is 0 at the launch. If we put in 0 to this, 20 times 0 is just 0. This times 0 would just be, or this to the 1. Yeah, exactly. That's why this number is our starting amount. If you plug 0 in for t, all of this just turns into 1, so it doesn't matter yet. A value is your starting value. Yes. Very good. Very good. Not Kuzi gets that it would be 1. That is excellent. Yeah, for these kinds of problems, I recommend just like throwing in some values for t and just see what happens. Think about, I have 7.2 Ethereum. I will take your 7.2 Ethereum and raise you by 19 over 21ths. Should not really be a raise. You want to do the next one, Levi?
There is no next one.
There is no next one. Impossible. I thought I killed the next one. Which I guess makes sense if there is no next one. Still getting over that octahedron problem.
That was super cool.
It was.
And that the explanation they had was awesome.
Yeah.
Okay. How much Earth do we have?
Earth.
Well, we have more nerdish dollars than Earth, for sure.
Oh, definitely. Now, does this mean the price of one nerdish dollar or the value is greater than Ethereum value? Or
Yes.
we have more nerdish money?
both. It's both things.
Oh, that's great.
Yes.
That's a best case
So
scenario.
we have more nerdish money, and nerdish money is always worth more than the comparable denomination of Earth. Or, yeah, of Earth. Huh?
Sit down. You're up.
We need some questions in the Discord. And if you don't give them to us, we'll take them from you. Does anybody have questions about the sections in general? Or do you have any grammatical, punctuational, situational
What did he say about
questions?
striking vipers?
I don't know. Let me find a random one. Yeah, find a random one that you find challenging or don't know how to do or something like that.
Not Kuzi. Are you referring to the Black Mirror episode of this previous season? Is this so? That's a very interesting question to ask.
Give away the finish. Give away the finish. Did you guys get a sub? No?
Do you?
Did you?
I shouldn't have to tell you that, Levi. You should know to say that.
Well, I was actually trying to respond to the question. Alright, we got a Will question. Oh, this one. This question, I don't like this question. It's fine, but I don't like it.
What about a trash balls question?
Where's that?
We've got a couple of questions here.
Was it done though?
No. Okay, so we do Alan's. We haven't done Alan.
I'm going off screen for 3 seconds.
Alan, trash ball, and Wa of all questions that we haven't done yet.
Oh, when did that happen?
I don't know.
Okay.
Past minute.
Oh, I didn't even see those. Alan, thank you. Okay, sorry. We should. What? 1. I just found a random question. 2, 3. Why are you counting? Broadvanix don't count. That's terrifying. What? We're doing an Alan question, and then we'll go back to the other stuff. Alan, question for you. What is the resolution on your monitor? Or are you taking pictures of your monitor with your telephone? Regardless of the answer, can you assume how I feel about these photos you have? I like them. You know what? I'm kind of looking at gift horse in the mouse here. I'm kind of looking at gift horse in the mouse. Oh, bet that's all you can count to, guys. Don't count too high. You won't be able to come down. All right. A town's chamber of commerce.
Is that Icarus?
Huh?
Don't count too high, like you're gonna fly into the sun type situation.
Yeah.
Keep reading.
Bird.
You know how I feel when people quote Icarus.
I know you do. Bird loves it when you quote Icarus at him. Don't Google Icarus. A town chamber of commerce printed a map of the business district. Very good, Matthew. The map is 12 inches square.
Yeah.
Wait, I don't know what that means. Is that 12 square inches? Or is it like 12 by 12?
I think it's 12 by 12.
Okay. And 1 inch on the map represents an actual distance of 300 feet. Sure. Okay, so let's do that here. We have a 12 by 12 map. This is drawn to scale, by the way.
Yay. That's probably not too far off.
So, 12 by 12 inches, and we know that 1 inch equals 300 feet in the real world. Okay. That says 3. Okay. On the map, a parking lot for one business is represented by a square with side length of 0.25 inches. Okay, so we have a square. This is not drawn to scale of 0.25 by 0.25. Someone look that up. Alan, you are so far behind. That stinks, dude. I also don't know what the yes means. Okay. So we have this square. It's a parking lot. What is the actual area in square feet of the parking lot? Be very careful. If you do 0.25 by times 0.25, you will get 0.62. No, you will not. You will get 0.0625, which is great. Is it? Is that what it is? Whatever. I'm going to change that to 1/4 and 1/4, so you get 1 over 16. I'm going to say, yeah, okay, so the area of this equals 0.0625 square inches. But you do not take this and multiply it by 300 feet. If you were watching yesterday, Brady did that question with the yards. I think it was a yard by yard by yard cube. And the scale factor needs to be squared or cubed or whatever is happening. So anytime you multiply, anytime you go from one-dimensional or distance to two-dimensional things to three-dimensional things, you have to multiply your scale factor again. Or before you even multiply these two together, you could do times 300 here.
No, it's not 300.
What?
1 inch is 25 feet.
What?
12 inches represents 300 feet. No, it says 1 inch represents an actual distance of 300 feet.
Yeah.
So 12 inches does not represent 300 feet, which for some reason is what you thought.
Yeah.
Right.
But thank you.
Oh, yeah. No. I mean,
This demonstrates why you should always try. Because at least you feel good. Right, Bert?
Yes.
Yes.
Hey, keep going.
Yeah, I'm going.
Okay.
So we're multiplying by 300 for both of those, right? And then you would get, if you're multiplying these, you should just get by 300 squared, right? You have, if you're multiplying all 4 of these together now, right? So that's what has to happen. So 37 is whatever the result of this is. I don't want to do it. Yeah, I do. Actually, it's 90000, and then you're multiplying that by 1 over 16. I don't know what that is. Whatever that is.
5,625.
It is 5,625 square feet.
Yeah.
Yeah. Oh, this is so nice.
Oh, is this
Okay,
so
and
square?
now is it larger? I can't read that. Can't read that. Okay. The larger version of the same map of the business district is printed with a side length 50% longer than
That's
the side
so
length.
long!
Is so much longer than the side length of a previous map. On the larger map, what is the actual distance in feet represented by 1 inch? Oh, I understand. Okay, well, what is the best way to explain this one, Birdstar?
What is the new side length going to be? Start with that.
Well, the new side length will be 18 by 18 feet.
Yeah.
That's true. Okay, so now this new one is something like this, also not drawn to scale. 16 inches. That's not 16 inches.
No, you're doing your best.
18.
Wait. Yeah, 18, I see what you're saying.
Yeah.
Now, it's probably good to find the original length in feet of the business district that the old map represented. 12 inches, each inch is 300 feet. We have to do 12 times 300 to find the original distance that this map covers from side to side. So 12 times 300 is going to be 3,600 feet. I am not mistaken.
Yeah.
So 18 inches needs to represent the same actual distance that the old map represented. We just blew the map up a little bit. So 18 inches must represent 3,600 feet. To find 1 inch, you divide by 18. Oh, you got it. Okay.
Does that make sense to everyone?
400 divided by 2. Yeah.
it would be super problematic if it also equaled 300 feet. That means if you made bigger maps, the world would increase in size.
Dude, that would be literally insane.
It would be literally that way.
That would be literally insane.
Was this a Matthew question? No, this was an Alan question. Alan, do you have any follow-up questions on your Alan question? Answer us in 15 minutes.
Is Alan gone right now?
No, Alan just is super far behind. I don't know why Alan's stream lags, but that's what happens.
Yeah.
Ooh, this looks fun.
Some people are born with a lagging stream.
Yeah? I heard that too.
There's not much they can do about it.
Yeah.
Some people are born with a lagging stream, some achieve a lagging stream, and some have a lagging stream thrust upon them. Oh gosh. I feel like that joke was right up your alley. I'm not sure why you didn't laugh.
Yeah, that's a good point. For a doofus.
Nerdish.
All right. We have an expression. Then we have other expressions. Which of the following expressions are equivalent to the given expression? Okay, so last ditch effort, plug in values. They don't limit what you can have s to be, so I might say, well, plug in 0 for s and see what happens. Let's just do that really quickly. If you plug in 0 for the given expression, you get 0 minus 2, so negative 2. And then you have 0, 0, 0. So you have 2 plus 4 thirds, which is 10 thirds. Awesome. Let's plug in 0 for the other ones. You get 0 for A, you get 0, 0, 0, negative 2 times 1 third. That's not the same. 0, 0, 0, negative 2 times 1 third. That's not the same. 0, 0, 0, 2 times a third. That's close. And why isn't this working?
Yeah. That's very good. You put in 0 for s.
Yes.
So you have negative 2 plus 4 thirds.
Oh, negative 2 plus 4 thirds. I did 2 plus 4 thirds. Okay, so this would be 2 thirds. So therefore, it would be negative 2 thirds. So first one works, second one works,
Yeah.
third one and fourth ones don't work. My bad. So A and B are okay if you plug in 0. Then you could plug in, yes, thank you, not Kuzi.
1.
So you can plug in 1 and do the same thing. The other way to do this is it looks like we are... Oh, that's interesting.
The only terms you have to adjust, I mean, they take out 1/3 out of everything. Don't do that yet. Just think that the s in the first parentheses would be combined, like terms-wise, with the negative 7s. So we should end up with negative 6s, and then the negative 2 will be applied to the positive 4 thirds, which is going to bring us down to negative 2 thirds. So once we have that, almost everything is over 3 except for the third term.
Yeah.
So what does that bring us to? We have
7
thirds
7 thirds
s
s
cubed.
cubed.
Thank you.
Yeah.
Plus 7 thirds s squared. This is now going to be only minus 6s, and this is going to be minus 2 thirds. So they pull a 1/3 out of everything. You're making this extremely difficult for everyone involved. So we also need to make 6s over 3 so that we can pull a 1/3 out of everything.
Totally illegible.
It's so hard to read, which is... So multiply 6 by 3 over 3 to make it 18 thirds.
I feel bad.
Yeah, you kind of should. Anyway, then you can take a third out of everything, and you're going to end up with what A says.
Hey, Matthew. What's this? What is this?
Oh yeah, Matthew, you seem to know.
What is that thing? Can
You
you
seem
tell
to-
everybody about it, Matthew?
Yeah, why would I use whatever that is?
Where would I use it?
Where do I go in general with my life?
Yeah, tell us these things, Matthew.
Does that help me figure those things out? I hope so.
Okay. Well, this was a pretty terrible explanation. If this doesn't make sense,
You know why it
please
was
let us know.
terrible is
No.
because you drew all over what I had. It was going to be mediocre at best, and then you made it awful.
That is the least helpful thing we've ever done.
That you've ever done.
Oh.
That you've ever done.
That was the least helpful, well-intentioned thing you've ever done.
That's not true.
Yes, because what you intended was very unhelpful because of me.
No.
Yes.
What I intended was very helpful. But then I'll do
You
some. Yeah.
Yeah, Matthew, what is that?
What is it? We don't know.
Matthew, tell us about it.
Where
And
did-
keep in mind that Alan will find out in 15 minutes. So if Alan needs to know something, say it sooner. All right, let's look at the next one.
Plug it in, plug it in.
I don't want to do this one. Can you do
is
this one?
around. Fine.
Thanks.
Ugh.
You've never seen this one
hate
before.
this one.
You've never seen it before.
Plug it in, plug it in. You're acting. Wait, go up, go up, go up. There's an equation we need.
You can probably do it without it.
No, I can't. Good. Crop it.
I'm gonna
Get rid of the bottom. Yeah, there we go. Great minds think alike. Ha ha ha. Ha. Hey. All right, I'm not
Take it away,
happy
Trey.
about this, but I'm gonna do it. What time is it, Levi?
It's 7:04.
Very good. C is equal to 5/9 F minus 32. Let that sink in. Great, it's sunk in now. The equation above shows how the temperature F, measured in degrees Fahrenheit, relates to a temperature C, measured in degrees Celsius. Based on the equation, which of the following must be true? And then we have these three options here. So let's go through them one by one, because obviously we would not want to go through them two by two, because we'd run out after the first two, and then we wouldn't be able to count three, because it'd be a remainder. Number one, a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Oh, wait, Levi.
Yes.
Ring Matthews just crushed it.
Did he?
Loosely translated from Latin, Alta Ipsum means summit yourself, or do the best you can. A web-based organization, planning, and grade tracking tool, Alta Ipsum is designed to help students understand their strengths and weaknesses, study more effectively, and achieve their goals. That's definitely right from the website.
Matthew, tell us about this.
Yeah, Tight Bond Wood Glue. Why do Levi and I, why are we sponsored very furtively by Tight Bond Wood Glue?
It's a very furtive sponsorship.
As sponsorships go.
I would say it is a very furtive sponsorship, yes.
Hey, we get another follower.
Thank you, Prodvanix.
We love our followers. Don't listen to what anyone else says. I'm kind of manic today.
I have noticed that.
Yeah, it's nice. I like it.
We're sponsored by Mania. Look it up in the American Psychological Dictionary thing. What's it called?
The DSM.
Look it up in the DSM.
Yes.
We're sponsored by Mania.
Mania.
Okay.
But you aren't sponsored. That's right. But we are sponsored by Tight Bond Wood Glue because of Levi and I. We have a tight bond, specifically for
Wood glue.
Wood glue.
It's the industry standard. Professional strength, interior use. Sands easily, short clamp time.
That's our favorite part. It's got a short clamp time.
Yeah.
I can't tell you how many wood glues I've used that have a very long clamp time.
Yeah.
It's a pet peeve.
Yes. Also, water cleanup.
It cleans up water?
Yeah, it does. Notice, it sands very easily. It has a short clamp time. Water cleanup. Which of these in this parallel structure question on the writing section of the SAT or English section of the ACT doesn't fit? It's the last one. Water cleanup.
Trapsy, you made it just in time for Tight Bond original wood glue. Anyway, Alta Ipsum is free for Alta Ipsum is free for a month. You should check it out when school starts. It might help you with your organization. I am Prodvanix. No, I am Prodvanix. Levi? Levi would do that as well. Doubt it. Thanks, Levi.
Yeah.
Anyway, can we get back? You guys are so distracting. A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. All right, so let's think about this for a sec. If I were to multiply this 5/9 out by what's in the parentheses, I'm going to basically end up with slope-intercept form. I'm Groot. So I'll just go ahead and do that. C is equal to 5/9 F minus, wow, I do not want to do this right now. What is that? 5/9 times 32. Levi, can you do that?
What?
5/9 times 32.
You don't have to.
I know, but just do it. I want to just have the number there. I want to just show them what's going on.
No, but you can multiply by 9/5 to get it out, and then you don't have to do it.
No. Levi,
I don't
I
wanna
know
do
that.
it.
There's a way I want to explain this.
I don't want you to explain
My
it.
phone is
5
right there.
Divided by 9 times 32 is 17.77777.
You're
Do you know what
done.
the next number is?
You're done.
Okay.
This is slope-intercept form. Our slope is 5/9, and then our y-intercept is negative 17.7. Let's look at the slope real carefully. The slope, 5/9, or the schlope, as our uncles say. You're usually thinking in terms of like rise over run. We go up 5, we run over 5. We run over 9. And when you first learn graphing, that's a very good way to think about it because it's true. And it lets you find new points very easily. You go up 5 and over 9. However, there is another way to interpret this, which is this. Your rise is 5/9. Your run is 1. So you rise 5/9 of a unit. Shoot. Every time you run 1. All right? Just to show you kind of what I mean. Let's say our slope or our slope was 1/2. That would mean that we'd start at this point. We go up 1, and then we go over 2. So our next point would be here. And we draw a line that looks like this. All right? But according to my new definition, this would also be going up 1/2 over 1. Going up 1/2, going over 1, we end up there, which in fact is a point. Okay? So slope can also be thought of as the rise as you go over 1 unit. The change in y as x changes by 1. Okay? So in this case, our change in C would be 5/9 for every 1 degree change in Fahrenheit. Not sure which one you're on, but just plug in 32 and 33 for easy numbers. Very good, very good. I'm talking about slope right now. Just a nice, interesting way of thinking about it. Anyway, so a temperature increase of 1 degree Fahrenheit does give us a 5/9 increase of degrees Celsius. So that would be true. I will put a check mark next to that to show that we check marked it. I have a bubble in my throat right now, Levi, but I don't want to clear it because I sound kind of weird. I'm gonna keep it going. Number 2, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. It's still in there.
Dang it.
It's all right. That just kind of hurt.
Sorry.
It's gone now. Now it's gone. Okay, so this is very similar, but it's asking from the other's perspective. So now, if Celsius is like our x value, what's our slope that makes our Fahrenheit change a certain amount? If I were to solve this for F instead, I'm not going to do it, but if I were, I would have to multiply everything by 9/5 eventually. So what I would get is F is equal to 9/5 C, and then there'd be some adding some stuff, which the y-intercept I don't care about right now. So 9/5 is 1.8, which means that yes, our Fahrenheit is going to increase by increased by 1.8 degrees for every 1 point increase in Celsius. Whew, that's a lot. So that is also true. We love that. We love that. And then 3, a temperature increase of 5/9 degrees Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. Well, that conflicts with number 2. Both of them are talking about a 1 degree increase of Celsius, and 2 says that means that Fahrenheit rose 1.8 degrees, and 3 says it only rose 5/9 a degree. So if 2 is right, which I believe it is, 3 cannot be simultaneously right, so I will cross out 3. Which means 1 and 2 would be our answers, or at least our correct statements, and so you'd find the answer that represents 1 and 2. And then you're good. You're golden. You're good to go. You're set to chill. You're something else that makes sense too. Excellent. Are there other questions?
No.
Good, we finally finished them. Whew. That was a close one.
Ooh, well, now that we've finished all the questions that exist, maybe we should be done. Or you can ask us more questions, which is much better.
Go! 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 Dude, go! Every time you say that, I have to do it.
Go!
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 Yeah.
We got a new question from Matthew.
Yes, Matthew. Thank you, Matthew.
All right.
The fuel economy
Hold on.
of a vehicle
Hold on.
in miles per gallon.
Hold on. I'm going to crop this so well.
Yeah.
Yeah. High five.
Okay,
This
thank
is
you. All right, so we have the fuel economy of a vehicle in miles per gallon can be modeled by a quadratic function of the vehicle's speed. Okay, so that just means the faster you're going, or if you're going 0 miles per hour, how many miles per gallon are you getting? 0, right? If you're just idling the car. But if you're going 2,000 miles an hour, that's not super efficient. So there's going to be some sort of bell curve, not a bell curve, but a parabola that's upside down. That will, at some speed. No, don't go.
Who left?
Come with questions, okay? Not Kuzi, didn't leave. So, a team of engineers is testing a new vehicle for fuel economy and finds that its maximum fuel economy of 30 miles per gallon is achieved at a speed of 48 miles per hour. So, let's just draw a picture of this real quick. It'll be relatively simple and not particularly accurate. So, at 40, right? 40 miles per hour? Yes. 40 miles per hour, we hit 30 miles per gallon. So we're going to be there, and then on either side it's going to be like that, because they told us that this is the maximum fuel economy. So it can't get any better economics, unless it's in Earths. Did I spell this right?
What?
It's a theorem? Okay,
Yeah.
it's not another U in there. Okay.
Yeah.
So it's achieved 48 miles an hour. Thank you, Matthew. Thank you, Matthew. Thank you, Matthew. You are correct, sir. Okay, cool. In high-speed tests, the fuel economy is found to be 14 miles per gallon at a speed of 88 miles per hour. So this actually is coming in handy. So this is 14, and at 88 miles per hour, we're at 14. So we have there, and we have there. Yeah? Okay. What is the expected fuel economy at a speed of 58 miles per hour? Okay. Are there answer choices here?
Yes.
Yes. All right, great. So we have two data points, right? We have yellow. B. So we have 48. Oh my gosh. Everything's ruined, Bird.
Yes.
48, 30. We also have 88, 14. We want 58 B, or something like that. So that's our setup. Now, how are we going to find this out? We're just looking at these, so these are all very close to each other. So we're not going to be able to eliminate stuff. So this is going to be a quadratic of some sort. And we will have the miles per gallon, which, do we have a variable for that? No. So let's say E for economy. No, that's not a good choice. Don't use E as a variable because of E, the other thing.
Euler's number.
I think it stands for Earths, actually, Bird. Okay, so let's call it F for fuel economy. Very exciting. And then we have speed, so S is speed. Okay, so our equation is going to be F of S equals A times S squared plus B times S plus C, which I assume is 0, right? Because if you're not going anywhere. Right, Brady? Can I just say that?
What?
So the fuel economy of this car, because it's a parabola, would be negative. Well, A would just be negative. We figured it out.
Yeah, that makes sense. Oh, A is just negative. Yeah.
So I would say plus C, but C is going to be 0 because at 0 miles per hour, it's going, this is going to hit, this is going to hit the origin. So it's just plus 0 here, so I'm not going to have that. Does that make sense? Matthew? Did Matthew ask this?
Yeah.
Okay. So we have this, And now we're going to plug in the values to be able to solve for A and B. So let's plug in, none of these are nice, okay, whatever. So we know that 30 equals A times 48 squared plus, what am I doing? B, that was not the right way to do it, times 48. We will also plug in these. So we will get 14 equals A times 88 squared plus B times 88. So this is a system of equations with two variables. They are constants, but we're going to treat them as variables in this system of equations so that we can identify what they are. And then we'll put them in the actual equation, plug in 58 for S, and that will give us our value here. I'm going to change that to an F of 58. Matthew, does this approach make sense to this question, what I've done here? What did you try this question, it didn't work, or you just found a question and it seemed challenging so you threw it at us? Either way is fine, but I'd like to know where you stumbled, if you did. Stumbler?
Stumbler.
Great. Okay, so, hey Bird, can you do some math for me?
Yes.
What's 48 squared?
48 squared is 2,304.
I don't want to do this. Matthew, I'm not going to solve this system of equations. But once you solve it, you plug those values in for A and B, then you plug in 58 for your S values and solve for F of 58. Or that, just whatever that is will give you F of 58. If you'd like me to solve it, I will. I just don't want to, and I assume that that's not the challenge of this question. The challenge of this question is setting up your system of equations. This is a hard question. Show. I'm Matthew's friend. He asked for me. That guy, and yeah, it does make sense. Oh. Why'd he ask for you? That's what friends are for, I guess. Do you have any other questions? Do we have any other questions?
Do you have any other questions?
I asked you first.
Yes, that's kind of true.
Cool. I'm glad it makes sense. I'm going to erase it and make it go away. Please ask more questions. We got another 10 minutes. But you're not supposed to use a calculator. Oh, really? Let's see. Is there a better way to do this without a calculator?
Okay, the fuel economy of the vehicle in miles per gallon can be modeled by a quadratic function. So you have your, okay, 48, 30, yeah. I don't see how they'd expect you to use a calculator if the answers are 29, 29.9, and 30.1. I think that's a little bit aggressive. At a speed of 88. What is the expected fuel economy at a speed of 58? Oh, geez.
There's no way you're supposed to not. Look at the answer choices down here. The answer choices are that. There's no way you shouldn't be using a calculator. It does say no calculator at the top, but I think that's just a mistake.
Where does it say no calculator?
There's a little calculator with a cross through it, right next to question 105.
Oh, wow. Okay, so, well, wait a second. If you use vertex form, you've got your H, you've got your K, all you need is to find your A, so you only have one variable to solve for.
So you're saying if our vertex form is f of s equals
whatever A is.
A times s minus
48
squared. We have to do 48 squared, that's annoying. Plus 30.
Okay.
So it's still the same situation, I would think.
Yeah. Oh, you'd have to put, okay, so the only other point we have is the 88 and 14. So you'd have to put those in.
You'd have to put in, you have to square 40. I mean, this
Yeah.
is not, it's just horrifying.
Yeah, okay.
They made a mistake by saying this is a no calculator question. Yeah.
Oh, Levi.
Ooh.
Oh, no, wait, before you change it.
Yeah. Brady's
Yeah.
idea is better. Well, this is also difficult. This system of equations, at least they're linear. This one is not so linear because then you're solving for s when it's squared, so you have to factor it or do quadratic formula or use your calculator.
We've actually, you know what? This is not that bad.
Oh no, you're right. You're absolutely right.
Right, so we know that 88, 14 goes in here. So 14 is our y value, is equal to a times 88 minus 48 squared plus 30. So this minus
That's what you
that
call.
would be 40.
40 squared is 1600.
Yeah. So 1600a plus 30.
So negative 26. Yeah, a has to be
A is
negative.
negative, right.
So then 1600 divided by 26, if you want to do that.
Okay, so we have negative 26 is equal to 1600a.
26 goes into 160 6 times, and it would be 156. And
I'm
you-
going to simplify the fraction first. And then it's, which is only going to take us one step. Okay. So then we'd have to do long division,
Yeah.
which is going to give us something very small.
Yeah, so 13 goes into 86 times.
No, other way around.
Oh.
800.
That's terrible.
Yeah, I mean, we can do it. It goes into this one time. 13,
Well, don't just change this to an 8. So it's 13 divided by 8. Just do that.
and then,
And then divide by
Divide at the
100.
end?
100. Yeah, later.
okay.
If this doesn't help you, that's fine. Ask us more questions.
Let's see this through. Okay, 13 divided by 8. It's going to be 1.
You switch markers.
I can't, dude. It's 'cause I only have another marker. Oh, 8 times 5, 8 times 6 would be 48. Okay, 2. Is this going to give us a nice answer eventually?
Well, this
Yes,
isn't even the answer.
This is it. No, I know. This is, okay, so 40, so 5. 1.625 is A.
And then
but it's
divide by
negative.
100.
Negative 0.01625. So our actual equation.
Oh, dude,
give me
we don't even need to make this a decimal. We'll just keep it as a fraction. It's 13 over 80. Negative 13 over 80.
Negative 13 over 800.
Negative 13 over 800.
Okay.
And then you just plug it in.
Plug
so this
in
becomes
58.
negative
8 over 300. Negative 13 over 800.
negative 13 over 800.
Okay. They're asking us what's the miles per gallon?
58,
One
so
speed
it's
is
10,
58.
so it's 100, so it's negative 13
Oh, this
over
is
8
not too
plus
bad.
30. So 13 over 8 is, so it should be 30.01.
Okay, so if we do it over here, so we have negative 13 over 800 times 10 squared, because it's 58
10
minus
squared is
48.
100, so it's negative 13 over 8, which is 1.625, so it should be 30.2. If D is 30.2, that's the answer, with no calculator, which is still way too much work. This is a calculator question.
Oh, shut. Well, if this is not from SAT or the SAT the section of the quadratic, or SAT section of Khan Academy, if it's from like the specific lesson on vertex form, then maybe this is supposed to be no calculator.
True, yeah.
So yeah, what did we say 13/8 was?
8 13ths?
No. Is it supposed to be?
Sorry,
No, it's
13
13/8,
eighths.
yeah.
It's
One-
1.625.
1.625. All right. Okay, 5/8, right. Okay, so we get 28.325. Is that it? 28.325? Yeah.
Oh, right, I didn't. Yeah, no problem, that guy. You should also ask us more questions.
Was that one of the answers?
Not on the actual thing. Oh, maybe it was. No, it's 29.
What did we screw up?
It doesn't matter.
Dude, you can't
This
do
should
that
be
to me.
0.75 or 0.375, right? Oh, wait, why is that one up? I clicked the wrong one.
All right, see you, that guy. Great job.
Have a good dinner. Nice. Yeah, bring your questions. Bring 30 questions. Work on a ton of stuff. Bring a ton of questions. This is really hard. I don't know if you're studying for the SAT or ACT. So if you're not, then we might not be able to answer the harder questions that aren't on the test because we try to focus on that. But if you are, bring those test questions. Have a lovely dinner. Save us some. Put it in the fridge in a little tote bag.
14 minus 48 is 16. Hold on, wait. One last thing, dude. Trust me.
I trust you.
Any other questions right now?
No.
All right, one last thing. So we said it was A.
Someone
times-
please ask us a question. Oh, it's 7:30. Okay.
And then we said this was 14 when S was 88.
Do you want to stream this part, or you want to just do this for you?
What did we screw up here?
I don't know, dude.
We screwed something up.
Yeah, probably.
Minus 30 would be negative 16. Oh yeah, the A is supposed to be way easier.
All right, everybody, have a good night. We will see you on Tuesday.
Oh wait, here it is.
What?
This was we're supposed to get negative 0.1 as our A.
Why?
We had the wrong. We turned this into like negative. Something went wrong here.
Oh my gosh.
Our
Have a good
A
night.
was so much easier.
Bye.